pounds, kilograms of leukemia was obliterated by their CAR T cells over several weeks. We want to generate CAR T cells that can lift heavy weights, that can go the long distance. The B cells disappeared, but then they come back, resetting the immune system.
Our reporting from the International Society for Cell and Gene Therapy annual convention is made possible thanks to the support of Cellares. CAR T-cell therapy started with Kymriah, and Kymriah started with Professor Bruce Levine. Since Kymriah was first approved almost 9 years ago, thousands of patients have been treated and cured. I am Federico Citterich reporting for Onyx Live here in Dublin at the ISCT. I had the pleasure of interviewing Prof. Levine, and I asked him about where the field stands today. Professor, good afternoon. Thank you very much for joining us.
Yeah, pleasure to be with you.
Professor, you're the co-inventor of Kymriah, the first ever CAR T-cell therapy. Around 10,000 cancer patients have been treated with Kymriah. Did you ever think when you were in the lab that your work would have saved so many lives?
No, we were thinking about experiments first, right? We were thinking about how to engineer T cells and test in a clinical trial. And that's what we had done up until that point. Now, we had worked on CAR T cells before, but in HIV. And we saw a modest effect on HIV viral load. In 2010, we treated our first patients in cancer. And this was in adults with chronic lymphoid leukemia. Pounds, kilograms of leukemia was obliterated by their CAR T cells over several weeks. So seeing the data come in, it was just a revelation. It wasn't a miracle at the first time because you think it can be a trick, right? But then it happens again, and then it happens again. And eventually we could see that we had something very special.
Professor, I understand you've been keeping a running wish list of new ways to boost CAR T effectiveness. So could you perhaps name the 2 or 3 that you think are most important?
Well, I can't stop at 2 or 3, right? So we want to generate CAR T cells that can lift heavy weights, that can go the long distance. We want to generate CAR T cells that can turn left, turn right, stop and start. It's about control, increasing the potency of CAR T cells, and also covering a wide array of targets. And we have people working on all of those, and we're excited to see the data that's coming out.
In the context of manufacturing, do you think that manufacturing platforms are coalescing or perhaps becoming more fractured?
I think manufacturing platforms are diversifying. In the beginning, cell and gene therapy was a small field. We had very few companies interested in making the equipment and the reagents that would allow us to manufacture the cells. Now that we have seen such tremendous growth in the field, we do have more companies developing more devices, and that helps our work because it helps us in the manufacturing field to test these therapies.
I also wanted to have your opinion on the explosion of CAR T for autoimmune. So what's your take on that?
On one hand, you could think it was logical, right? B-cell mediated autoimmune disease, let's test this. But it took a group in Germany treating a small number of patients at first to show that this could really work. And I think it wasn't a surprise that CAR T and autoimmune could kill B cells. What was a surprise is how well it worked. And a second surprise was the B cells disappeared, but then they come back, resetting the immune system. So we still don't really understand in autoimmune disease why the B cells tend to come back sooner, but still it recalibrates, and it is inducing some very long, durable remissions in these patients.
And what about your take on the transition from autologous to allogenic therapies?
I honestly don't think it's a transition. I think there's going to be coexistence of different types of CAR T-cell therapies. We have autologous first. We have some interesting results in Allogenic, and there may be an approval in a year or 2. But I'm also looking at the emergence of in vivo CAR T-cell therapies that I think can provide wider patient access and at a much lower cost of goods. There still will be a role for ex vivo autologous therapies because there are ways that we can manipulate the cells ex vivo now much more efficiently than we can currently do in vivo.
Just to have also your view on what do you think or what do you expect will be the next big CGT breakthrough?
Oh, that's hard to choose. Look, we've had autoimmune, we have in vivo. I think the next thing we look for, and we see some reports here at this meeting, is the ability to do in vivo gene editing efficiently. Now that can be done in the liver with lipid nanoparticles, but if we can target lipid nanoparticles, I don't think we want to do that with lentiviral vectors, but lipid nanoparticles that will deliver gene editing components and do that efficiently in immune cells, that will be a leap forward.
And CAR-T has only been approved for liquid tumors so far. Solid tumors have been much more difficult. So at high level, what's the main reason for that, you think?
So maybe we can ask another question. Why were liquid tumors so easy, right? They were so easy because they're clean targets. CD19, some CD20, but the approved products are CD19 and BCMA and myeloma. In solid tumors, there are challenges because there is not that near perfect antigen. Solid tumors can have antigen expression very high for targets, but those are also expressed at lower levels on healthy tissues. And then you need to discriminate between the tumor and the healthy tissue. Also, solid tumors, there's heterogeneous expression of an antigen. You can kill part of the tumor, but the rest of it escapes. Solid tumors also tend to be much more immunosuppressive than the liquid tumors. So we have challenges, and also include the challenges of getting the CAR T cells inside the tumor. Liquid tumors, single cell suspension, accessible from all angles. Solid tumors, you have a big ball and a matrix often, like pancreatic cancer. It's very difficult to get immune cells. So the way that we're addressing this, amping up the CAR T cells, armoring, enhancing the potency, and in the case of brain cancers, glioblastoma in particular, direct injection to the brain. And we've seen remarkable results in brain cancers, now not near to the level and not to the duration that we see in liquid tumors, but still we've seen some very promising results.
And you were president of ISCT in the past, so I also wanted to ask you about the evolution of this conference. How has it been, moving on until today?
I think it's an explosion. When I was first elected, I was president-elect for 2 years, starting in 2018. We had 1,400, maybe 1,500 members. Today, we have 4,500 members. So look at that fold change, and that corresponds to the growth of the meeting, where we have 800 posters next year, maybe we'll have 1,000. We have many parallel tracks. We have filled up this convention center in Dublin. There is a buzz and an excitement about the meeting, and ISCT is stronger than it ever has been.
Professor, really appreciate your time. Thank you very much for joining us.
Yep, thank you so much.
Thank you to the International Society for Cell and Gene Therapy for supporting Onyx Live.